Hi friends, welcome to another edition of Quick Tip videos brought to you by dataplatformcentral.com. So in this weekly edition, we are going to see another one of those ADF tips which got recently introduced. In the previous video, you saw one of the recently introduced features in ADF which is known as the flowlets. In this edition, we are going to see another small but useful feature which got introduced in ADF. This is basically an extension to the Azure Cosmos DB connector which was previously available in ADF. Now the difference is that the new connector has added the support for Cosmos DB change feed capture. Change feed capture is a feature within Azure Cosmos DB, an inbuilt feature just like the CDC in SQL Server. Every time a data modifies or a new data gets added to a container within Azure Cosmos DB, the change feed capture will keep on monitoring the container and start transmitting the data changes as it happens to your Azure Cosmos DB container. Which means that if you are able to get the data that is transmitted by the change feed capture, you will be able to get the continuous data changes or modifications happening on a Azure Cosmos DB container. This makes it a good candidate for incremental processing of the data while you are capturing it from a Azure Cosmos DB. So in this quick demo that you are going to see, we are going to implement this change feed capture feature of the Azure Cosmos DB by utilizing the connector inside ADF pipeline, and through that we are going to capture the changes as it happens inside your Azure Cosmos DB database. So let's see the demo in action. So now let's go to the Cosmos DB instance, go to Azure Cosmos DB demo source repo, and this instance will be now blank. So we need to create a database and a container inside the database. For that purpose, you need to go to Data Explorer, and you see there is nothing under data, so you need to create a new database. So you can click on new database, you can name it some database name, maybe you can name it like model DB because we are going to store some product model. So let's name it product model DB, and let's click on OK. And inside the database you need to create a container. The container is where your data sits. So first create the database, then create the container inside the database. Then once the container is up, you can then populate the data into it. The easiest way to populate bulk data would be to upload a JSON file. So the database is now created, and inside that now you can create a container. So you can click on new container and you can name it like product models. That's the name of the container. If you want to add analytical store, you can do it, but here we don't require it. So at the end of this, you will be having a container created inside your database which is called product models. So the container is now created. So if you go to the items collection, inside that you have the upload item option. This is what we will be using for uploading bulk data. So let's click on upload item and let's browse to the folder where you have copied your model list. So I have copied to this folder, and then click on upload. And in a short while you can see all the records uploaded. See, it automatically got uploaded. You have 118 items created inside your container. So these items will be created as documents because your Cosmos DB is actually a document DB. Now if you refresh that, you will be able to see all the items here. Currently it is blank, so you can see all the 118 items here. So this is the initial data that you have populated inside your Cosmos DB instance, and you also have set up the SQL instance. Now that your source and the sync systems are ready, now it's time for you to go and create the package. So now let's go to data factories, go to the data factory same instance. So the data factory instance is now up, and we have gone to the Azure Data Factory Studio to create the new package. So let's go to the author tab, and in the author tab you can add a new pipeline, change feed capture demo. This is the name of the package where we will be creating all these artifacts. So the pipeline is created. Now we need to start by adding a data flow. So we'll add a data flow task. Then let's go to the settings where we need to point it to a data flow. We'll click on new. It will automatically create a new data flow object. Inside that you need to add the source, which will be the Azure Cosmos DB in this case. So it will ask us to point to a data set. We'll be clicking on new and creating a new data set for Cosmos DB SQL API, and click on linked service. You can select your subscription here. You can select the account name, which is demo source repo, and inside that you have now created a database called product model DB. So select product model DB, click on test connection. So now the connection will be successful and you will be successfully connected to the instance from your ADF. So click on create, so that the linked service object will be created, and here you have to now point to the collection, and the collection that you have created is product models. So click on the connection and then click on, automatically the schema will be imported from there. So click on OK and you'll be able to see the correct schema here. So if you go to the schema now, you'll be able to see the 3 columns which is available inside your Cosmos DB. So you go to Cosmos DB and check any item, you can see that these are the 3 properties which are associated to the item. So let's go to the one of the items. You see there is product model ID, there is name, and there is modified ID. All the other these columns are the system columns which are added by your Cosmos DB. So you can see there are 3 columns which are identified correctly. Now the main thing that you need to do here is to go to the source items, and you have 2 options here, change feed and include system column. So first select change feed, and then it will automatically give the option of start from beginning. You can check or uncheck, but keep it checked. So these are the 2 settings which will make sure that the change feed capture data is captured by the ADF pipeline. So this will ensure that the ADF will, through this connector, connect to the standard change feed feature which is powered by Azure Cosmos DB. It will start pulling the data as transmitted by the feed capture, and the start from beginning setting will ensure before it starts the actual transmission of changes, it will take one snapshot of the Cosmos DB as it is now, and it will apply it to your ADF pipeline, so that you will get this data which will be stored in your SQL database as on the starting of this activity. Any further changes will be continuously captured by the feed capture, and it will be brought into your table by the ADF package. So if you want to now see a preview of the data, you can turn on the data flow debug. It is going to take a while, so you need to wait until the debug cluster is ready. You can see it in the notifications that it is still creating the clusters. So wait until the cluster is ready. The data flow cluster is now ready, as you see in the notifications tab. So now if you go and refresh it, you'll be able to see a preview of the data as it comes from your Azure Cosmos DB instance inside your ADF pipeline connector. So you see all the user defined columns like product model ID, name and modified data are included. All the other columns that you see inside are the system columns which are generated by your Azure Cosmos. So now that you are getting the data correctly, now you can go ahead and connect your sync to it. We will be dropping the data as it is to your sync database. So that means we are going to maintain the history as it comes through the change feed capture. So let's select the sync here, and the sync is going to be pointed to your Azure SQL database. So let's create a new data set which is going to point to our Azure SQL database. So inside that you see Azure SQL database. For the new data set, you can click on continue, and of course we need to create a new linked service for the same. So click on new, and then you need to select the subscription, and you can select the server name inside that. So we are going to point to ENT SQL server, and inside that you have the database which is demo sync repo which was created for this purpose, and the username and password you can key it. This is the username and password you created while you provisioned the server instance inside Azure. Now you can give a test connection to make sure that the connection to your instance is working fine. Once you are sure that the connection is successful, you can go ahead and create the linked service. Once you create the linked service, the next main thing is to point to the table. Now in this case we are going to create a new table, so you need to click on edit and you need to give the name of the table. So let's name it dbo.product model data, and let's click on OK. So the table will be created against the database. So one thing you need to ensure is that you need to give the import schema option to none, because there is no schema. So you can click on OK, and the table will be now created when you run this. At this point the table is not created, but when you execute this pipeline, the table will be created on the fly based on the schema which comes from your source. So you can go to the mapping, you can make it auto mapping. If you disable it, you can see all the columns that it is flowing from the source. So you can just keep it auto mapping itself, because you are going to create a table based on incoming data, and you can go and do an inspect to see the column names which are correct. And if you want to see the data preview of the data which is going to get inserted inside your SQL table at this point, you can again click on the preview. It will make use of the debug cluster, and it will pull the data as it comes from your input stream, which is your Azure Cosmos DB connector, and it will show you a preview of the data as it comes. So now that you are happy with the data, now it's time for you to start executing this. So for that, first we need to validate and make sure that there are no validation errors, and as it shows there is no validation error now, you can close it. And the second thing that you need to do is you need to publish all your changes. So the publishing will ensure that the pipeline that you created, the data sets you created, as well as the data flow, all will get published to your Azure Data Factory. This is essential before you start executing the data flow inside the pipe. So let's wait for a couple of minutes and you will get the publishing successful message. Now its publishing is completed. Now you can go ahead and go to your pipeline, and in that you can see the add trigger. So click on trigger now and you can click on OK. So now it will take a while whilst it is executing this data pipeline. Inside the monitor tab you can keep on refreshing, and every time it sees what is the current status. Currently it is in execution status, as you see. So keep on refreshing until you see the execution being success, and now you see that the green tick has arrived, which means that the execution is succeeded. Now you can expect the data to be available inside your Azure SQL database table, which you have created for this purpose. So let's go to the SQL Management Studio once, and let's ensure that the table has been created. So when you expand the databases, you can see the database that you created for this purpose, which is demo sync repo. Inside that you expand tables, and you should be able to see the product model data table now being created, and you can see the product model data table now. So if you right click on it and choose the select option to show the 1000 rows, you should be able to see all the data. We have around 118 rows, if you remember. The 119 documents with data were present inside your Azure Cosmos container. So you should see around 118 rows here. So as you see, there are 118 rows present here, and with all the required data, that is the product model, the name, and the modified data. Now if you try for a simple query like select count of product model ID, which is the primary key or the unique identifier for the documents, you can see that there are 118 documents. Now you can go ahead and try to do some inserts or some modifications inside the data and see how that reflects in your SQL database. So let's go back to the Azure, and what we can do is that we can directly go and update the items. So if you go to the items, you can go to any random item. So I'm going to an item which is having product model ID of 86, and the name is ML Mountain Tires. I'm just adding just a text to that to modify it, telling that it's amended, and I'm just changing the date to the current date. So I'm making it 2021 12 and just giving say 11th. So I'm updating a row here which is having product model ID of 86, and I'm going to add a new item now. So I will copy this and I'll click on new item and I'll paste this, and I want to pass an ID here. So I'll just pass a random ID here. And so I'm basically adding one new item, and I have amended an existing item. And here the product model, I'm just going to give it like 3333 just for identifying, and I'm just going to add test product model. So I've added a new test product model, and I have also amended one with the ID as 86. So I'm going to save this, and it will get committed to your container. So now if I go back and run the pipeline, it should pick up both these changes and it should add it, preserving the history to your SQL table. That means you will have now 120 rows. So 118 rows which are already there plus these two changes. For every modification it will add a new entry, and for every new addition it will also add that as a new entry. So you should get 2 additional records. Now that you have done the change, let's go back and let's rerun this. So let's go back to the pipeline, and I'm again going to trigger it now, and let's wait for this particular execution to be over. So the execution is now success. So now let's go and check the database contents and see if the changes has been picked up correctly by our ADF connector by virtue of the change feed capture feature. So let's go back to the SQL Management Studio. Let's first list out all the records. You should see 120 records. As you see, now it has become 120 rows. Now let's check what happened to the entry with ID 86. See, the first entry is there, which is on 1st June 2007, and the second one I created now 11th December 2021, and the name also has been changed to amended, which means that it is picking up the changes correctly. This was one of the modification we did, and it picked it up as a new entry because it is preserving history. We are just dumping the data as it is, which is provided by the change feed feature. Now let's see the new entry as well. So if I make it 3333, I can see the new entry which I added, which was the test product model. So you can see the new entry as well, which means that the modification and new entry was picked up by the change feed caption. So if you push the data as it is to your system will preserve the entire history. But quite often we don't want this. We don't want the history to be preserved. What we need to do is that we need to ensure the latest status is maintained in our system rather than the entire history. So in such cases, we might have to add some additional logic so as to make sure that any modification that is happening in the source, we need to do corresponding modification in our sync table as well. And for the new entries, we need to insert them. So basically we need to do an insert in some cases and an update in some other cases. So let's see how we can tweak the existing ADF pipeline so as to ensure that we are getting the latest status inside our sync table rather than preserving the entire history of data. So let's see how we can do that. Let's go back to the ADF Studio, go inside the data flow. And so here what we are doing is we are getting the source as it is and pushing it to the sync. So instead of this, what we need to do is that we need to have a reference. So for reference, we need to add another source. So this time the source will point to the destination. That means the Azure SQL database. We are going to use it as a reference. So let's click on new. Let's click on Azure SQL database. Let's click on the last linked service that we created. And let's point to the same table, the product model data. And now we can pull the schema from the table because the table has already been created. So click on OK. This is going to create another source which will point to your destination table, which is for creating our reference dataset. So now we need to select lookup. So this lookup will ensure that all the incoming rows are compared against your existing table, and whichever entries are present in the table means it's a modification. Whichever are not present are new entries. So what we do, we'll use the primary stream as source 1 and the lookup stream as source 2, which means we need to compare between these two sources, and it has to be based on any row. All we are concerned is like if we are getting at least one match, and it should be based on product model ID, which is the main column which can be used for uniquely identifying an entry. So now that we have added the lookup, now what we need to do is that we need to add a alter row modifier. This is for adding under what conditions we need to go for an update and under what conditions we need to go for an insert. So we will use the lookup output as the input stream, and you need to specify the row conditions here. So we need to insert if what we need to do is that if the corresponding lookup column is null, we need to insert, which means it's a new column. Output column, we can take the column from the lookup output. So let's take source to product model ID, and we are going to use isNull function. This is going to return true or false depending on whether it is null or not. So in this case we are looking for null, so we need to compare it against true, which means that whenever the product model ID value which is coming from the lookup is null, which means that it can't find any match, then it's a new entry, so we need to insert. And again we need to add the corresponding logic for update. So we'll put update if, and again we can copy paste this condition. The only difference would be there, instead of true we look for false. So we have added both the conditions. So now it will automatically mark these rows as insert or update. Now all we need to do is that we need to go to the sync, and here you need to, instead of allow insert, it should be allow insert and allow update, and the key column will be product model ID, and the mapping as usual. Instead of product model ID, now we need to change it. There are two product model IDs. You need to make sure that you are taking the one coming from source 1. Similarly for name also, it should be coming from source 1. Modified data also should be taken from source 1, because source 1 is your main stream. The source 2 stream is just used for lookup. It's not used to take any data. It's just a reference data set. So once you set these two things, you can again make sure that the columns are coming correctly, and you can even look at data preview if you want. And once you're happy with the data preview, now you can go back and try running it. Before you run it, you need to make sure that you truncate the table. So just execute a truncate table statement so as to purge the existing data which is already there inside your table. So let's go back to the data flow and rerun it. Now go back to the data flow, and the first thing that we need to do is go to the source and disable the change feed, because we had already enabled the change feed. Now for again rerunning it, we need to disable it, otherwise it will not pick up the entire list of data, because it will be only looking for the data changes. Now we want again a repopulation of data, so we will remove that setting. We will publish the changes. I have removed it and I have published the changes. Now if I go back and validate it, everything is fine, and I added a trigger and I triggered it now. it is going to execute and pull me all the records as it is from the source. And now you need to go back to the notification. You can click on view pipeline run as usual, and then you can start clicking on refresh to make sure that the execution of that pipeline is success. Keep refreshing and eventually you see your data flow being successful. So now if you go back and check your table, you should see the 119 rows, and you can see 119 rows as we expected. And if you see, you'd still be able to see the 3333 row which I created in addition to the existing data, the test product model, which means that it is correct. Now what we need to do is that we need to again run the change data feed. Now this time the only difference is that we will not set the start from beginning because we don't need a repopulation. We have already done the repopulation. Now go to the data flow once again, and inside the data flow go to the source, and here we have this disabled. Enable this, but take out the start from beginning option, which means that don't repopulate it, just pick up the changes that is happening after this. So let's see this in action. Let's again publish this. So the publishing is now completed, and we have set up the change feed option but without the initial snapshot. So now if you go and trigger it, it should execute it, only capturing the changes. Before that, let's go back to the Azure Cosmos, and we are going to again add one more. So I'm going to add 5555 as a new entry, and I'm going to add it as test model 2, and let's change the data as well. Let's make it 2012, and I'm going to add this new item. So one item I have added again, and again I'm going to update another item. But still, if you see, you'll have only the new item entering as a new entry, and the updation will be modified. So let's update the product model ID with 111, and instead of water bottle, I'm going to make it water bottle amended. And again, as usual, I'll change the date to the current date. So I'll make it 2021 12, and again I'll make it 21, and I'm going to update it. So again, one update and one insert. But the difference here is that for the update it will modify, only for the insert it is going to add a new entry. So let's go back to the package. Let's again trigger the execution of this package. Whilst this is in execution status, let's click on the view pipeline run option. Let's go to the monitor tab and keep on refreshing. Now you can see that finally the execution has now become successful. So let's go back and check the database once again. As expected, we can see 120 rows here, and if you see the new row that we have inserted, the 5555 row, we can see that the 5555 row is now present inside your table with the correct description that you added. This is test product model 2. And now if you compare the other change that we did, that is the one with the entry 111, we can see that still it contains only one entry, not the two entries as it happened in the last case. The difference between this run versus what we did in the beginning was like we captured the changes as it is and committed it to our table, so that every new modification created one additional row. Here we did a lookup and we ensured that only the new entries are inserted, and for the entries where the property values have changed, we update the property values inside your destination. So what you see now is the current description that is present. So we changed it from water bottle to water bottle amended, and we also changed the corresponding date. We made the date as 21 December 2021. That is the date that you see here. So as you see, we can make use of this change feed capture feature which is present inside Azure Cosmos DB to get the changes as it happens inside your container, transmitted through a ADF pipeline, and depending on how we want to implement the logic, we can pull the data as it is if you want to preserve history, or we can add a lookup logic like what we did now, so as to make sure that the modifications are applied as modifications in your final table itself, and the new insertions are inserted as new rows. So this quick demo helped you to understand how you can make use of the change feed capture feature available inside your Azure Cosmos DB so as to derive incremental data out of your Cosmos DB containers. It's a good addition that the Cosmos DB connector in ADF now supports the change feed capture straight out of the box. As usual, keep sending your feedback and let me know the comments on the videos. Feel free to follow my channel for getting useful tips like this every week on Azure Data Services as well as on Power Platform. Feel free to subscribe to my channel and press on the bell icon for getting notifications. Meet you all soon in another quick tip in the next week. Till then, have a nice time and wish you all a Merry Christmas.